In Lesson 9, we are going to create tables of equivalent ratios. Example 1 is talking about paper mache, which is a mixture of water and flour. And they tell us for every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. So let's use those values to start our table. 2 cups of water to 3 cups of flour. Now what we need to do is find equivalent ratios for that relationship. And for a lot of us, the easiest way to do that would be to double them each time. If we had 2 cups of water and we doubled it, that would be 4 cups of water. And for 4 cups of water, we need 6 cups of flour. We multiplied 2 times 2 and we multiplied 3 times 2. You can find equivalent ratios that way as long as you are multiplying both numbers by the same number. So for example, if I tripled the amount of water, that means I multiply it times 3. 2 times 3 would be 6. And then we also have to multiply the cups of flour by 3, which would mean 9 cups of flour. Let's try multiplying the original amounts by 4. If we multiply the cups of water, the original cups of water, by 4, we would get 8. And then if we multiply 3 times 4, it would be 12 cups of flour. Let's do it one more time. If we multiply the original numbers by 5, 2 times 5 would be 10 cups of water, and 3 times 5 would be 15 cups of flour. These are equivalent ratio tables because each of the numbers, each of the ratios will simplify to 2/3. Ratio tables can also be made horizontally. In this case, we're talking about Javier, who is designing websites. And he's paid a rate of $700 for every 3 pages of web content that he builds. We're going to create the ratio table to show the total amount of money that Javier is earning. And we're going to start with the value that they gave us. They gave us a rate of $700 for every 3 pages of web content. Our top row is the number of pages built, so we'll put 3 in there. And when he builds 3 pages, he is earning $700. In the same way that we worked on the table before, we could double the number of pages built, and 3 times 2 would be 6. So we also have to multiply the amount of money that he earns by 2, which would be 1,400. If we multiply the original pages and money by 3, we would get 9, and 700 times 3, which is 2,100. If we multiply the original by 4, we would get 12 and 2,800. If we multiply by 5, we'll get 15 pages and 3,500. If we multiply the original by 6, we'll get 18 pages and 4,200. If we multiply by 7, we would get 21 pages and 4,900. And finally, if we multiply the original numbers by 8, we would get 24 pages and 5,600 for the amount of money he's earned. After you've completed your table, you can answer these questions quite easily. If Javier is saving up to purchase a used car that costs $4,300, how many web pages will he need to build before he can pay for that car? According to our table, he would need to have built more than 18. So we could say 21, or we could say 19, because we're only 100 away And one more web page would get him more than $100 if you look at the rate. $700 for 3 web pages would be more than $100 per web page. So we could say 19 based on that piece of information. In exercise 1, they talk about cornmeal juice, which is a good way to prevent fungal growth on plants. It's made by soaking cornmeal in water and then using 2 cups of cornmeal for every 9 gallons of water. 2 cups of cornmeal, 9 gallons of water. Complete the ratio table to answer the questions. So we're going to double it. 4 cups of cornmeal would be 18 gallons of water. We'll triple it. 6 cups of cornmeal would be 27 gallons of water. Times 4, 8 cups of cornmeal would be 36 gallons of water. And times 5, 10 gallons of cornmeal, cups of cornmeal, would be 45 gallons of water. How many cups of cornmeal should be added to 45 gallons of water? There it is right there in our table, 10. Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? Well, if he has 8 cups of cornmeal, clearly he needs 36 gallons of water. Then what can you say about the values of the ratios in the table? Looking back at it, each of these ratios can be simplified to 2/9, and that's what makes them equivalent. Each one simplifies to 2/9, so they have equivalent values. Exercise 2 is about setting up a fish tank. James is buying a breed of goldfish that typically grows to be 12 inches long. And it is recommended that there be 1 gallon of water for every inch of fish length in a tank. That is the standard for all fish tanks. The recommended ratio of gallons of water per fully grown goldfish in the tank is a little tricky. Because in this case, when we're talking about a goldfish that grows to be 12 inches long, if we only have 1 goldfish that is 12 inches long, we need 12 gallons of water to accommodate that very large fish. Once you have your original ratio, this table should fill in pretty easily. If I have 2 goldfish, that's 24 inches of fish. So we need 24 gallons of water. If there are 3 goldfish, we should have 36 gallons of water. Please notice the relationship between number of fish and gallons of water. It is times 12 because these particular goldfish grow to be 12 inches long. 4 and 48. And finally, if we had 5 goldfish, we would need 60 gallons of water. We can then answer the questions. What size is needed for James to have 5 fully grown goldfish? We filled that in just a moment ago, 60 gallons. How many fully grown goldfish can go in a 40-gallon tank? Now, we don't have that value in our table, but we can't have a partial fish. So a 40-gallon tank would only be able to handle 3 goldfish. It is not large enough to handle 4. The values of the ratios in this table, they are all equivalent to 1/12 because they all simplify to 1/12. Please complete the problem set so you are prepared to move on.